Hey guys, I wanted to make a video on the Desk Tidy project that a lot of you are doing for Year 10 graphics. Simple video on how to use sheet metal and how I arrived at this very basic solution for the assignment. So what I might do first of all is I'm just going to show you a couple of photos that I've taken. So you would have worked with your teacher to develop your own cardboard model, and so with that you get an idea of if it's going to hold your products and suit your needs. I'm not going to go into great detail about this. This is what your teacher will do with you in class. But what your teacher should have done is created, got you to draw on top of your development or your net, depending on how they're calling it, and figured out the distance between your fold lines, any angles for your folds, okay, and a width for your sheet. So we're going to be referring to this image quite a lot throughout the drawing of this, so I'm just going to keep it open here, and I'm going to minimize Inventor just so we can see both at the same time. I'll try something like that, see how that goes. Okay, so what you're going to do is you're going to start a new sheet metal So we want a metric sheet metal drawing, and I'm going to click on that. Once that's loaded in, just like always, we're going to click the XZ plane there, and I'm going to start by drawing a rectangle. So you'll notice with sheet metal it looks a little bit different. Okay, we've still got a sketch. The 3D part won't always work for you in sheet metal. It's a little bit different. We've got some different names for some of the things that we do. But the whole concept of having to do a sketch before you create a solid component is the same. So let's start off with a sketch, and I'm going to go to rectangle, and I want a 2-point center, and I'm going to select the center of my drawing like always, and I'm just going to draw this the same way that I'm viewing it over here. So at the moment I've got a 140 wide by 50. We'll start with that one. So let's do a 50, and then I'm just pressing tab and 140, and I will press enter. I'm going to zoom out. So there's my 50 by 140. I'm happy with that, and I'm going to go finish sketch. Sorry, 50 by 140. So I've just drawn that top rectangle there. The next thing I'm going to do is I'm going to press face. Now this is the equivalent of extrude, if you like, and I'm just going to click OK. What I don't know yet is how much that extruded, so I didn't get to put in any information there. I just was able to click face. I couldn't put in a value for the thickness. But if I double click here on sheet metal defaults, I'm going to deselect use the thickness rule, and I'm just going to whack in 3mm because most of you are using 3mm acrylic, and so I'll click OK, and you'll notice that it's grown in thickness already. So it's grown to that 3mm in thickness. So the next part that I'm going to do is I'm going to do a 90-degree bend, and I'm going to travel for 30mm. To do that I'm going to use the flange command. So I click on flange, I select that surface there, and I'm just going to put in my distance of 30mm that I'm getting from here, and there's my 90 degrees. Click OK, and that's done. So it's starting to take shape. If I take a look and we go back over here, I've just drawn this back panel and the top part there. We now need to come down this way. So I'll come back over to here. So now we're going to travel for 65mm, and I'm not too sure, well I do know because we did practice, but I wasn't too sure of that angle. So we'll have a look at how I arrived at that as well. Let's go flange. I'm going to select that surface. I want the distance. We know it's 65. It's the angle I'm unsure of. I put it next to a set square, and it looked pretty close to 45. So let's put in 45 degrees. And at the moment, it's a bit hard to tell whether that's sitting nice. So if I click on this surface here, I might even spin it around. And what I want is, I want those two surfaces to line up so that this surface stays parallel with the desk if it was sitting on a desk. Here's a little trick that I learned. I just zoomed out and I'm using, it's a bit crude and there's probably a better way. So someone can add comments and add to the learning of everyone if they figure it out. I'm just using this as a straight edge and I'm going to play with my degrees until both surfaces match. So if I put in 50 degrees, it's going past, so I know it's between 45 and 50. So let's try 48. Oh, what do you know, it works. Okay, so 48 gives me that really nice bend there. So I'm going to click OK. Now what I'm going to do is I need to do another bend here. Shift middle mouse wheel to scroll around. So sorry, I'll use the correct terminology. Flange, it's not a bend, it's a flange. I'll select that one there and I know that this next one is 15 and I've already written on here at 90 degrees. So let's go 15 mil and my angle's going to be 90. Click OK. And so that is now, ooh, not having much luck here with my isometric tool. Okay, so now it's starting to look pretty good. If you wanted to put holes in it, you can draw a sketch and use the cut tool and put holes in it like that. If you're not liking the sheet metal layout, you can always do this. You can go to, I was going to convert it. Yep, here it is, convert to standard part. For some reason it was grayed out at the start. So I'm going to go convert to standard part. I can now click on there and it behaves as if it was a standard part. I can then extrude and I can cut that and I click OK, and then I could do a pattern if I wanted of that feature. Go in that direction. I'm not going to spend too much time or give too much detail here because it's not really the purpose of the video. So I'm just going to do this real rough for now. And so there's some pen holders. And that's how I would do that. So I can flick back between sheet metal and standard part quite easily. And I quite like doing that because I like using the features of a sort of 3D model standard part to do my modelling, because let's face it, that's what I've done most of my time in and that's what I feel comfortable using. So I can put a radius on there if I wanted. And just start cleaning this thing up, making it look a little bit more pro, so it doesn't have sharp edges. Let's just say I've finished this and it's looking really good. I'm going to convert it back to sheet metal now. And what I want is I want to be able to get a flat pattern to get a DXF for the laser. So I'm going to say create flat pattern. And all that's done is it's created this drawing that I've got here essentially. And I can switch backwards and forwards between the two as much as I want. If for some reason it won't create a flat pattern for you, make sure you've given it a thickness in here. Sometimes that has caused me some grief. But yeah, that's the easiest way, is just to go to between fold apart and flat pattern. I'm then going to select the surface. I'm going to right click on it and I'm going to export the face as, and then that's where I can just give it a name and save it as a DXF. You can then take that DXF over to the laser. There's plenty of other videos where I've shown how to do that, and your teacher will show you how to do that as well. This is more a video on how to use the sheet metal component for your assignment. Just to add to this, guys, there is a way to print your fold lines. However, I found that they were creating almost like stress fractures, and when students were bending the acrylic it was cracking on those lines if it wasn't hot enough. It's much easier just to have this plan in front of you, mark where your fold line's going to be with a whiteboard marker, and do your folds in the workshop using that. Hope this video helps.